Hey everyone, this is Math Guy Channel here, and today we're going to be going through inverse graph and relations. So inverse, if you haven't heard it before, it's kind of like kind of like reverse, where you have a point, like you swap the x and y values. So you get a point like 1, 2 for example. So 1 is the x value, 2 is the y value, and you swap it. So you get 2, so 1, 2, you get 2, 1, and that sort of thing. So that's inverse is obtained from swapping x and y values. You can do it with a set of coordinates, and it also works for a set of functions. So if you have a so in a inverse function, the domain and range are swapped as well as the x and y values. If the function is 1 to 1, then it will have an inverse that is also a function. I'll get back to that later. So the notations for an inverse function of f of x is f negative 1 of x, and the domain needs to be restricted to obtain an inverse. It sounds like a lot of gibberish right now, but let me show you what you mean. So for example, if I go here, you have x squared, and I said the domain so x is greater than 0. Yep. So this is a 1-to-1 function now, because it passes the vertical line test, and it also passes the horizontal line test. So when we mean by swapping x and y values, you can do that by having this function here, y equals f of x. It's sort of just flipping it, like kind of acting like a mirror. That's why you have the function f of x equals square root x. And you can see that there's a symmetry towards it. Let's see if I change this to -1 or something. You can see that I can't really do a proper inverse of that, because I'll need to have, because this is the square root of x, and I would need another part of the function down here. So that would be two separate functions put together. So hence, why only 1-to-1 functions work. And the same way if I flip the sign. Oops. Okay. There we go. And I want to inverse this. I would have to do a there we go. There we go. There, negative there. And this works for any sort of functions. If a function like this, x squared with the domain here, and there are endpoints, somewhere on the graph, that also needs to be reflected through the equation y equals x onto your inverse function. That way, it is an inverse. So use your point intersection f of x and f dash of 1 of x. It's actually better if I use the other function as an analogy. But most functions, you'll find that that will intersect each other. So let's say, for example, I have that's not a great example. 2x plus 1, something like that, and do the algebra, and you'll find that the other one would be 2y. So give me a moment. 2y plus 1, x minus 1 over 2 equals y. Okay. So if this function x minus 1, oh no, that's what I meant, 1 all over 2, and adjust the domain accordingly. This is also not a great example, so it's probably better for me to go back to the function I had before, square root of x and x squared. Okay. Yeah, like the functions, they'll most of the time that when they intersect like this, you can solve both of them. You can solve either of them by you see here they both intersect at the equation y equals x at this point, and usually it will intersect at 1, 1, but sometimes not the case. When that's not the case, you solve one of the equations for the equation y equals x. So for example, it would be a square root of x equals x, or whatever function that would be, because in this case square root of x and x intersect at x equals 1. Yeah, so now we're going to be going through literal equations, and this is sort of equations expressing polynomials of numbers. So it's really just a simple of understanding your algebra well enough to help them manipulate the variables. So for example, if we have this function equation here, mx plus ny equals kx minus z, and the question asks you to make x a subject, you move the variables around, like putting mx and kx to one side, taking x as a factor out. So you move the ny here, ny, and that should be the right answer. There's a negative there's a negative here. I hope that you can see after the equal sign. And yeah, so that's a literal equation. In some cases, you have simultaneous literal equations. So you have mx equals mx minus y equals k, and x plus ny equals 2d. In this case, you multiply 2 by a factor of m to get a third equation, 3, and use 3 take away 1. And afterwards, if you do that properly, you should get y equals this number. And with simultaneous equations, you can either use elimination or substitution, if you remember how to do that. So in this case, we're going to substitute this function y into 1 here, and we make the x the subject, and we get x as this monstrosity. And yeah, that's Inverse graphs, relations, and literal equations. And yeah, that'll be all.